Hi everyone, it's Emma back with another WJEC GCSE Chemistry video. This stuff today that I'm covering also is in AQA and edexcel, and I'm going to be looking at Group 1. So if you look at the Group 1 metals, if you look at the periodic table, the one at the top, that is the column for Group 1. So it's got lithium, sodium, potassium, rubidium, cesium and francium. And you need to know the patterns, or they'll call it trends, that happen in this group. Now, all of these elements that are in Group 1 all have one electron in their outer shell. In Group 2, they all have 2 electrons in their outer shell. So because they have the same number of electrons in the outer shell, all having 1, if they're in Group 1, they have things in common, but they're not identical, because as you go down the periodic table, the elements get bigger. They've got more ingredients, more subatomic particles in them. But there are trends to look out for. So first thing is, all of the metals in Group 1 are reactive. All right? Just said all right. As you go down Group 1, they get more reactive. The first 3, you have to know how they react in water. I'm going to link a video for you to actually see a scientist putting these metals in water. Now, these metals are not hard. So if you're ever asked to describe metals, you're not supposed to say that they're hard. They're strong, but Group 1 alkali metals are actually quite soft. And as you go down the group, they get softer. So if I was here cutting, I could cut these metals up in front of you with a knife. You wouldn't usually think about doing that with steel or something like that. But with Group 1 metals, they are very soft. And as you go down the group, they get softer. And that's because they get lower boiling points as they go down the group. So if you think of chocolate, I'm speaking about boiling points and melting points. So if you think of chocolate, when it's in the fridge, it's really hard, isn't it? But if you were to put chocolate outside, when it's close to melting, it goes quite soft. And that's what it's like for the Group 1 metals. So the first one I'm going to look at is lithium. So if you put lithium in water, you have to know in all specifications that lithium will float and fizz around the top. And that video will show you. The next one after that is sodium. So you've got lithium, then sodium. You need to know that sodium is a little bit more reactive than lithium. So when you put it in water, it also floats and fizzes a bit faster. But there's a key difference, and it forms a molten ball. And you can actually see it when it happens. It's like molten means liquid, and you can see like a ball surfacing on the top. So if I've seen a 6-mark question a few times on this, mainly foundation, where they want you to explain the similarities and the differences between lithium, sodium and potassium reacting in water. And they might even ask you to predict how rubidium would react. So sodium floats and fizzes a little bit more aggressively than lithium, but it also forms a molten ball. Next one down is potassium. And in school, we're not allowed anything more reactive than potassium. And we store them in oil so that they don't react with the air, the oxygen in the air, because they are very reactive metals. You don't really see them by themselves in life because they've got that 1 electron in their outer shell. They are desperate to get rid of it, which means they are very unstable. They want to react with things. Oxygen, water, whatever it is, they'll want to react. So potassium is more reactive than sodium. So if you were to put potassium into water, you would literally see it burst into a lilac flame. Some people call it pink, but the specification will only accept you calling it lilac, and the video should hopefully show you that. So they're the 3 you have to know about. What they like to ask, more of a higher question, maybe a harder foundation question, is predict how rubidium would react. And you would say, well, rubidium would be even more explosive than potassium, because as you go down Group 1, the metals get more reactive. I'm gonna link, I think it's called Brainiac. I'm gonna link a Brainiac video so you can see all of these metals reacting. But you have to know that lithium floats and fizzes along the surface. Sodium also floats and fizzes along the surface, but a bit more, a bit faster, and it also forms a molten ball. And then potassium, because it's more reactive than sodium, bursts into a lilac flame. As you go down group 1, the metals get softer, and they could give you some information in a graph where you've got to, I don't know, I've seen it in a foundation paper where you've got to fill in the blanks on the graph, and there is a trend, a pattern. So if, let's say for instance, got a graph of 4 things, terrible writing, but, and they've missed one out, they've missed this one out, and they want you to fill it in, you've got to follow the pattern. So as long as yours is bigger than, I could do that a bit bigger, but they're not too fussy. As long as it's in between the two and it's fitting a trend, then they'll be happy with that. More of a foundation question again, really. But they love to throw data at you. I'm going to do another video where I'm focusing on higher now. So this video is for higher and foundation. It's starting you off for group 1. If you are doing foundation, don't worry about the next video. Thank you for watching. I'll see you soon.